Number 17, the function f is given by f of x equals 3x squared plus 2x plus 1. The graph of which of the following functions is image of the graph of f after vertical dilation of graph of f by a factor of 2. Okay, so this is about transformation of function, and here vertical dilation by a factor of 2. So you can set up twice of f of x, okay, because it's vertically stretched by a factor of 2. If it's a shrink by a factor of 2, then you have to say, I have to say shrink by a factor of 1/2, then it's like this, okay? So when you substitute this f of x into here, so you're twice of f of x, 3x squared plus 2x plus 1. So when you distribute, 6x squared plus 4x and plus 2. Okay, so if you look at answer choices, B, it shows the same expression here. And then let's read their description. Because this is a multiplicative transformation of f resulting from multiplying f of x by 2. Okay, yeah, that's the correct description. All right. Number 18, the table gives the values of the function f and g at selected values of x. Functions f and g are defined for all real numbers. Let h be the function defined by h of x equals composite f of g of x. What is the value of h of 0? Okay. So h of 0, so you substitute 0 into x, then f of g of 0. Now g of 0 is right here, right? When x equals 0, what is g of x? It's 1. So I replace the g of 0 as 1. So f of 1. Now look at the table again. Now this time when x equals 1, what is f of x? So which is here. So your final answer, -2. Answer is A. Okay. Number 19, the functions f and g are defined for all real numbers such that g of x equals f of 2 times x minus 4. Which of the following sequences of transformations maps the graph of f to the graph of g in the same xy plane? So you need to understand what this means, right? F of twice of x minus 4, right? Okay, earlier we talked about like twice of f of x. That's a vertical stretch, vertical dilation by a factor of 2. But if you have f of 2x this time, then that's a horizontal dilation. So, but it should be opposite. So you should say this one is horizontally shrink by a factor of 1/2. Okay, it's like reverse of that. So this one is just a stretch, but same 2, but horizontally is like opposite. So you have to say the f of x dilated, or you can say shrinked by a factor of 1/2. And then what is x minus 4 stand for? That's 4 unit to the right. Okay, x minus 4 means translated 4 unit to the right. If x plus 4, then you should say 4 unit to the left. So if you look at the answer choices here, number 19, then look at D. So horizontal dilation by a factor of 1/2, okay, and followed by horizontal translation of by 4 unit, okay. Right. The graph shows the graph of the trigonometric function f, and which of the following could be expression for f of x. All right. So if you look at answer choices, you don't need to worry about amplitude or period. So your a value, b value all same, right? A value 3 and b value all 2. So only thing difference is you can choose either sine or cosine, and then what is the right expression. Even D, this is center line located basically right here. That's y equals -1. So that's the d value right here. So they are all same too. So let's say you talk about sine here. So then like let's say you start here sine. So that's clearly if you go up here, that's a pi over 4. So you should say this is not upside down, just like regular sine graph. You can say your f of x for sine, just 3, right? And then sine 2, well, we know that 2 pi over b. If you look at the graph, the one period is from here to here, right? Pi. So it's pi, so b is a 2. That's why you get this on 2. And then you can say x minus pi over 4 because horizontal translation. You start from here, right? Not here. So pi over 4 unit to the right. And then it shifted down, right? Shifted down. So vertical translation 1 unit down, so -1. So let's see, you have that. Yeah, that is answer C, right? Then what if you have a cosine, right? So you can try with a 3 cosine and 2. This is not going to change it. Cosine graph, it depends on where you start. So let's say you start from here, right? That's a one cosine graph. So you can say pi over 2 to the right, right? There's starting point. So x minus pi over 2, and then your center line -1 also. But as you see, you don't have that. So this one all eliminates, answer should be C. Okay. Number 21, let f be a rational function that is graphed in the xy plane. Consider x1, x equals 1, x equals 7. The polynomial in the denominator, numerator has a 0, x equals 1, and does not have a 0 at x equals 7. Okay, so on the numerator, you have a 0 x equals 1. That means x minus 1 is on the top, right, as a factor. But do not put x minus 7 because it said it does not have a 0 at x equals 7. The polynomial in the denominator has a zeros 1 and 7. So you can say x minus 1, x minus 7 like that. Now, multiplicity of zeros at x equals 1 in the numerator and also in the denominator are equal. So it could be like that, right? 1, 1. Or it could be 2, 2, like that. Same multiplicity or power, right? Power. Now, which of the following statement is true? So as you see, if you have the same factor on the numerator and denominator, that means there's a whole at x equals 1, right? And I notice, x equals 7, right? So you have a vertical asymptote. Vertical asymptote at x equals 7, okay? Those two things you can notice for sure. Now, if you look at the answer choices, which one? Is it both x wholes x equals 1 and 7? No. And vertical asymptote x equals 1? No, that's not true. That's a location of whole. So function f whole at x equals 1, vertical asymptote x equals 7. Yes, that's correct answer. And obviously this is not. Okay, so 21 should be C. Now, number 22, the increasing function p gives a number of followers in thousands. These are also thousands. For a new musical group on a social media site, the table gives the values of p of t for selected values of t in months. It's months. And since the musical group created their account on this social media site, if a model is constructed to represent this data, and which of the following best applies to this situation? Okay, so we have to see this one is basically linear or not, right? Those are answer choices A and B. It shows a linear, and the other one is exponential. But C is exponential decay because your R value is less than 1, but this one exponential growth. Okay, so let's see. So their difference is 10, and this one is 15, and this one is even bigger. And so I can tell this one should be exponential growth, right? Exponential growth model, right? How do you know? One more time. So their difference is here. So let me write down maybe. So this one is a 10 and this one 15. And this one is around 22.5. And even this one is bigger. I don't need to calculate. We know that it's greater than 22.5. So it's not linear, right? Because you don't have any common difference. And then this is not decay, right? So this one is even bigger. So it should be answered this one. Okay, you don't need to worry about plugging in those things. It has to be D. Now 23, the polynomial function k is given by k of x is like that. A, B are non-zero real constants. Each of the zeros of k has a multiplicity 1. In the xy plane, x-intercept of the graph of k is this. They gave you one real zero. And a zero of k is this one. Another one is a complex zeros. And then which of the following statement must be true? In polynomial function, if complex number is one of the zero, then conjugate, right? Conjugate. What is a conjugate? Conjugate is opposite sign of that imaginary side here, right? Imaginary portion. So negative 0.478, that's a real portion of the zero. But conjugate, so it's opposite sign of imaginary portion, so which is plus 0.801, or you can say I in the beginning or like this, right? So that conjugate must be another root. So if you look at answer choices, B makes sense, that must be true. And then if you look at it like other things, it said we know that total is a 4 because that degree of the polynomial is a 4, but it said 3 x-intercept, that's not true because another one is a conjugate, right? So you have a 2 imaginary roots, so you cannot have a 3 intercept, right? So it'll be 2 in x-intercept. Now k equals 0 has a 4 real solution. That's not already, you know that that's not true. And then that is a tangent at this point. That one is not clear since we don't know exact the function. The graph has a tangent line at 17.997. Well, we are not sure about that. So answer should be B. Number 24, consider the function f and g given by f of x is a logarithmic function like that, and then the other g of x also logarithmic. Now in the xy plane, and what are the x coordinate of the point of intersection of the graph of f and g? So when they talk about point of intersection, so you set equal to each other and then solve for x. So let's put it this way. Log, I'm going to omit base 10 because that's common log. X plus 1 plus log x plus 3. That's going to be equal to log x plus 9, right? And then one of the property you should know for log like m plus log n, then you multiply, right? So log m times n. Of course, when you subtract here, then it should be log m over n. Okay, if you're not familiar with this one, I'm gonna upload like another video for just like formula review, so you can watch that one later. So this one, when you add, so you multiply that x plus 1 and x plus 3, right? So log x plus 1 and x plus 3 using that plus rule, and right hand side just leave it like that. Okay, and then since you have log on both sides like this, you can just drop it here. But remember, you cannot drop log from here. Okay, you have to have only one log. The reason why you can only do that, because you take, let's say, base of the exponential function like that, 10, right? Then this 10, so we have 8 to the log AB, that is a B, right? That's one of the property of log. So you can kind of cancel that one. So you have x plus 1, x plus 3 equals x plus 9, right? So after you remove that log, and then let's solve it. So you multiply it out, x squared. When you void it out, then 4x. And then 1 times 3 is a 3, and x plus 9. So when you move it every term to the left, so x squared plus 3x, and then minus 6 equals 0. Okay, let's see. Oh, actually, there's a little mistake there. It should be x minus 1, right? Oops, x minus 1. Okay, so let's put it x minus 1, right? This is x minus 1. Sorry about that. So when you void it out, x squared, then plus 2x, and minus 3 equals x plus 9. So when you combine like terms, x squared plus x minus 12 equals 0. Okay, so and then you factor out x minus 3, x plus 4 equals 0, right? And then you get x equals 3 and negative 4. Now you have to think about domain, right? So clearly here, for log, that has to be x minus 1 has to be greater than 1, right? For the domain. And this one x has to be greater than negative 3. This one x has to be greater than negative 9. So you have to choose this one, right? So x has to be greater than 1. Then this one out, right? So only x equals 3. So A is your final answer. Okay? Make sure you check the domain. Number 25. What are all values of theta for 0 to 2 pi and 2 sine squared theta equals negative sine theta? So okay, let's move it and then let's solve this one. 2 sine squared theta plus sine theta. When you add sine theta both sides, now let's factor it. Sine theta and 2 sine theta plus 1. Okay, now when you solve this one, each factor equals 0. So I got sine theta equals 0. And then 2 sine theta plus 1 equals 0. So 2 sine theta equals negative 1. Sine theta is negative 1/2. Okay. Now, so from here, in this domain, 0 to 2 pi, theta is a 0 because sine 0 is 0 and also pi. But do not include 2 pi because you don't not in the domain. And then sine is a negative. So if you consider like all student take calculus, I believe you know what I mean here. And sine is a negative value, then either quadrant 3 and quadrant 4. And then your reference angle, since it's 1/2, sine is 1/2, that should be 30 degree pi over 6. So this one pi over 6 here, and this also pi over 6. So your final answer for this one here, this angle, which is pi plus pi over 6. So 7 pi over 6. And the other one is up to here, right? So then 2 pi minus pi over 6, so which is 11 pi over 6. So you have 4 answers like that. So answer B is answer. Okay? All right, let's move on. Now you have a polar graph here. The figure shows the graph of polar function r equals f of theta, and f of theta is right here. Okay, 4 times cosine 2 theta. That's the graph of this polar graph. The polar coordinate system 0 to 2 pi. There are 5 points labeled A, B, C, D, E. So let's mark it. Where's A? A is right here. B, C, D, E. Okay, E is at the origin. All right, so now if the domain of f is restricted, only 0 to pi over 2. Okay. The portion of the given graph remains consists of the two pieces. Okay. Two pieces between 0 and pi over 2. And then one of those pieces is the portion of the graph in quadrant 1 from C to E. Okay, so they talk about this one here, right? In quadrant 1, C to E, that's one portion. But they said two pieces. So what is the other piece, right? If you draw up to pi over 2. And which of the following describe the other remaining piece? Okay, so let's think about then this one here. So in the xy plane, that's a cosine graph, and then amplitude 4, and then your starting point is at the origin. So let's go up 4 here, and then go down 4 here. And period is a 2 pi over 2, which is pi. So let's see. Here pi, and then pi over 2, right? And then you can draw your cosine in here. So it's a positive, so you start from up here. So let's mark it 5 points. So this is not polar graph, but this one is just cosine of, for cosine to theta graph, but it will help you out to graph this one. So we know that then here pi over 4. So when theta is starting from 0, we know that is a 4. So that matches with this one, right? So start from here, and then pi over 4, your so this is r of theta, right? And this is a theta. So r of theta is at pi over 4 is a 0. So we know that that point here at E, so it moves this way, but theta is then pi over 4, right? Now at pi over 2, your r is a negative. So if r is a positive 4 at pi over 2, it's supposed to be this way, but it's a negative value, right? Your r. So instead of going this way, you're going this way, right? So pi over 4 located here then, right? At pi over 2, your r is a negative 4, so it should go the other side. So then let me expand it so it goes this way, right? So you can say here, theta is then pi over 2, and then it moves this way, right? So that also matches, right? So your r is getting smaller. What I mean smaller is the value itself is bigger, but it's bigger in negative side. So as you see that this one bigger in negative side here, and then it goes up here. Okay, so now they talk about the other pieces of his one here. So let's see which one matches. The portion of the graph in quadrant, so it should be quadrant 3, right? Here's the 3, because 1, 2, 3, 4 quadrant. So it should be quadrant 3, so not this one, and then it should be then E to D. Yeah, the answer is a D. Okay. Yeah. All right. So number 27. Physical therapy center has a bicycle that patients use to exercise. The height in inches of the bicycle pedal above level ground periodically decrease when used. So you have to kind of imagine. So this is a pedal location, and it's like 12 inches from the ground, and then this one going this way, right? Then this one pedal is like located here, and also it goes up maximum here, right? So that's a periodic function. The figure gives the position of the pedal P at the height of 12 inches above the ground at t equals 0. So right here is a t equals 0, and then this is 12 inches above the ground. Okay, that's what description said here. And if the pedal's 8 inches arm defines the circular motion of the pedal, so it'll go up 8. So let's say it's here, then 12 plus 8. So the height of, I don't know what time, I have to figure out, but height that point should be 12 plus 8 is 20 inches, right? And then minimum here then 12 minus 8, so should it be so 6? No, so it should be 4 inches, right? 4 plus 8, yeah. So okay, so we found out that maximum height and minimum height like that. Now if a patient pedals 1 revolution per second, so that gives you period, right? Period of this sinusoidal functions. So 1 revolution per second. Now which of the following could be expression for h of t in inches of the bicycle pedal above the level ground at t second? Okay. So we know that center line is a 12. So if you think about y equals a sine b x minus h plus c, like that, right? That's a standard form of sine. I'm going to use a sine because if you look at the answer choice, it's only sine. The amplitude should be then 8, right? You can say amplitude is maximum minus minimum divided by 2, right? So which is a 16 over 2, which is 8. So I know then should be 8 something, right? So not this one, not this one. So 8 sine. What about period? Okay, period is 1 revolution per second. So which is basically 1, right? So you can say 1 is a 2 pi over b, right? So b should be then 2 pi. Okay, so you have a 2 pi here and x minus. What is the h? Okay, so they give you starting point, right? Starting point when t equals 0 is a 12 inches. So sine is a starting point right here, right? So at 0 is the center line, which is 12 inches. So h is 0, so you don't need to worry about it. And here, now c is above 12 inches, so plus 12 like that. Okay, but why answer should be D then? Why is a negative here? Because we know that your height initially was 12 inches, but it's going this direction, so this one going down, right? Your y value height will be going down. So actually the graph of this, if I sketch it correctly, so let's say you have a 12 here, and here you go down, you subtract 8, which is a 4, and you add 8, 20, right? And 1 pi is 1 period is 2 pi over 2 pi, which is 1. So let's say 1 second here, right? That's period, and then this one half second. So it start from here, right? And then you're going down, right? So going down to up to here, and then go back up. So and then go up, and then go down again, right? So it ends the same location after 1 second. So this kind of graph will explain this situation. Okay, so should be answer D. Okay. Number 28, last one. Consider the graph of the polar function r equals f of theta. F of theta is this. Okay. In the polar coordinate system up to 2 pi, and which of the following statement is true about the distance between point with the polar coordinate? So f of theta comma theta, so which is like r comma theta here, right? Okay. So you can graph this one actually in polar coordinate plane, but to do that, like I did before, so draw this one in regular xy plane. So your center line 1, and then your amplitude is 2, so 1, 2, 3, -1, and there's no horizontal shift. And then your amplitude is 2 and 2 pi period, right? So you can draw box. Then you get regular sign. So this point, this point, this point. So you mark it 5 points, and then you go up like this, right? So that's a sine graph. Now this one helps me to graph your polar graph, right? So this one, you can say, let's say you mark it 1 here, this one 2. I'm drawing a polar coordinate plane. So this one 3, right? So in the beginning, when theta is a 0, you start from 1, right? So you start from 1 here. That's when theta is a 0. Okay, so that point. Now, so here's a pi, and this is a pi over 2. At pi over 2, your r value, this one theta, r value is 3. So pi over 2 located here, and r value 3. So it should increase, right? So you can say, you see that this one increase, your r value keep increasing up to here, right? So that's a pi over 2. Now when pi come back to 1, so here's a pi, come back to 1. So I'm going this direction now. Okay, and after that, it'll pass through like sometime here. I don't know. I have to compute that one, but that one is obviously it r is 0, so it's a negative. So where are you going here? So then you should go this way, and then let's see, when right here, that's a 3 pi over 2, right? 3 pi over 2, your r value is, so here's a 3 pi over 2, your r value is a negative 1. So instead of going this way, you should end here and then passing through here. So that means it'll go this way, right? So that point is your angle is 3 pi over 2, right? And after that, and then you know, your r value, I'm talking about magnitude r value is decreasing, and somehow it'll pass through 0. So decreasing like that, and then when 2 pi is 1, so here's the 2 pi and then 1, so it goes like that. Okay, so actually I'm interested in like what is that point right here. Let me mark it with a purple here. So what is that angle here, right? So when theta equals when r equals 0, so you can set up, right, equals 0. So 2 sine theta equals, when you subtract 1, negative 1. So sine theta is a negative 1/2. Okay, and then that's a quadrant 3. What is the angle to be negative 1/2? So that's a pi over 6, 30 degree, right? Pi over 6. And then when you add pi over 6 from pi, so that's 7 pi over 6, right? So that's 7 pi over 6. And then, so that is a 0. Right? Okay, so that means right here, 11 pi over 6 actually, yeah, so 7 pi over 6 when it goes here, and then come back, when it come back again is 0, right? That point. So that is 11 pi over 6, right? Because 2 pi minus pi over 6. So that point, so here, that point is 11 pi over 6. Okay? So after you analyze this one, let's read it. The distance increasing between 0 and 2 pi, positive, increasing. Yeah, that one is answer, actually, right? Because from here to here, keep increasing, and that's a positive. Then obviously, but let's analyze the other one. It said decreasing, so that doesn't make sense. What about this angle, right? So from 3 pi over 2, so which is right here now, and then until 11 pi over 6, which is going this way, right? That portion. So what is this one here? So then distance is decreasing. That's correct. But it's at increasing, so it's this one out, eliminate. So this one decreasing, and then let's see, f of theta is a negative. Yeah, this is a negative here, right? But actually, this one is R is not decreasing, increasing. Y is a negative, but smaller negative will be increasing. So this description is wrong, right? That's what. Therefore, D is also wrong. So yeah, A is right. You can choose earlier, but just I wanna analyze it. Okay. Yep, that's it for this graph. I mean, this one, and then I will continue to make the calculator section.